All right, so I'm here this afternoon to talk to you about best practices in Scala. And just to give you a bit of background on me so that you understand why I actually can talk about these things, I'm the CTO of a company called BCDO. We recently merged three completely different teams, one doing Node, one doing Java, and one doing Scala. And we're trying to come together with the same processes and technologies. It's working out about as bad as you'd expect. But we have finally agreed that Scala was probably the language we all wanted to use. And this is giving me a pretty interesting perspective because I'm getting to see talented developers that know nothing about Scala or functional programming struggle with learning the language. And I'm rediscovering all the things that really troubled me as I was learning the language. So I'm seeing lots of problems that keep coming up, and I'm writing down these problems and solutions to them. And this presentation is the best ones, the most common ones, the most interesting ones, or the completely nuts one that I want to share with you. So the way this is going to work is I'm going to show you some code. You are going to have to work out what I think is wrong with the code. Explain it to me if we can, or if we don't have the time, I'll just give the solution. I'm going to tell you what's wrong with it, how to work around it, and then we move on to the next one. So let's get started. The very first bit of code that I want to show you is this. So hang on, how does this work again? Right. So why do you guys feel that I don't like this code? I'm just comparing two arrays in Scala. Now, this is a bit of a hint. Often, the title of the slides is a good idea about what the answer is going to be. So here, quite obviously, the problem is with array comparison. Can anyone tell me why this is probably not great? Okay. The main problem with that is that it doesn't actually work. Array is the only collection in the entire Scala collection library that doesn't have a working equals method. So comparing arrays like that is going to not work ever. And we know that. We as Scala developers, we have had that problem before. So we don't use arrays, or when we do, we don't compare them that way. But to beginners, to people who come from a Java background or a JavaScript background or any other background, this doesn't make any sort of sense. This is completely nuts. The reason it doesn't work has to do with the way it's encoded in the JVM. Arrays have reference equality, not value equality. It's not super interesting. It's just, it doesn't work. So instead of using equals for arrays, use same elements. And again, you have to know that, and it's going to bite you sometime if you don't know it. So I've shown it to you here, and if you didn't know about that, great. I've just saved you hours of pain in production. Right, so that was my first problem with array comparisons. And given the fact that this is Scala Days, I'm also going to try and, for every single one of these problems, explain how they are fixed or improved or not at all in later version of Scala. And so for arrays, Scala 2.13 has immutable arrays, which behave sanely with regards to equals and lots of other stuff. So if you're using immutable arrays, it's perfectly fine. Mutable arrays, even in Dotty, as far as I can tell, are completely nuts, and try to stay away from them if you can. Right, so this bit of code, which looks perfectly fine. Does anybody have any clue why I don't like it? Come again? Right, so this is not the first time somebody gives me that answer. I probably should change this slide. This is completely correct, but not the point of the slide. Again, there's often a hint. The problem here is that I haven't type annotated my method, so it could return any time, and the compiler is going to try to infer it. And the best time it can infer, the best type it can infer here, what you'd expect it to be option of A, especially given the fact that I have named my method as option, it's actually going to be a sum, which is not a massive deal most of the time. If you have a sum, it's a subtype of option, so it's all right. But it could be a problem, say, if this is a library, and I were to publish that, then the type of the method actually changed, and you break binary compatibility just like that. So when you have public methods, public members, type annotate them, because otherwise you will eventually break something, and the types that are inferred are not actually the type you think are inferred, or at least not all of the time. So just fix it that way, put an explicit type annotation, and then everything works out just fine. This is kind of improved in Scala 3, because implicit members have to have a type annotation, but at the same time, implicits are being deprecated in Scala 3, so it doesn't actually change all that much. So this is still pretty much a problem in 2.13 and Scala 3, as far as I know. And do put a type annotation on any of your public members. Unicode operators. This is problematic. Can anybody tell me why? So first, what is this code supposed to do? This syntax here is expected to read, create a tuple whose left member is 1 and whose right member is 4 divided by 2. And this is what would happen if you wrote that using the ASCII operators, and the documentation tells you that the ASCII operators and their Unicode equivalents are exactly the same. They are, in fact, not the same. This does not compile. But if you were to use the ASCII operator, it compiles just fine. So the problem here is very subtle. The problem has to do with operator priority in Scala, where the rules are a bit weird and hard-coded, but if your operator starts with an hyphen, with a minus, then it's going to have lower priority than, say, divide. But this character here does not start with a minus. So it's not actually the same operator as the ASCII arrow, contrary to what the documentation explicitly states. So this is very confusing. And it is better, most of the time, to use the ASCII operator instead, even though it looks much nicer with Unicode characters. There are ways to still have a nice display. You can use fonts with ligatures. You can use some advanced editors, such as Emacs, have pretty printing. But it's not going to be a problem much longer anyway, because it's deprecated in 2.13. So if you guys, like me, had rules to turn all of your ASCII operators into Unicode because you like that, you're going to have to revert that, because it's soon not going to compile anymore. Enumerations. What is wrong with the way this is implemented? First, does anybody not know what enumeration is? Okay, we're going to assume everybody does. Does anybody then know? Does anybody then know why this is problematic? I couldn't quite hear that. I'm sorry. That is a very good answer. Where to start? So there's a lot of problems with that. Mostly the whole thing is problematic. But the one thing I'm going to focus on, because I think it's pretty important, is that once you have written your enumeration like that, where you have declared an enumeration of type status with members OK and not OK, then this code is going to compile without any sort of warning. You can pattern match on a value of type status.value and have a non-exhaustive pattern match. It's going to compile, and it's going to fail at runtime. And we don't like it when things fail at runtime. Especially since in Scala, we tend to assume that pattern match is smart, and it's going to warn you whenever it's non-exhaustive. This compile without a single warning. It crashes at runtime. It's everything that's wrong with a lot of the errors that we have in Scala. So don't do that. Don't use enumeration. Use sealed trait hierarchies instead, where the way this works here is I've declared a sealed trait. Sealed means that there cannot be any subtype of status declared outside of the file in which status was declared. So the compiler knows that having declared OK as a subtype of status, not OK as a subtype of status, and those are the only subtypes of status in this file, there cannot possibly be any other subtype of status. So the compiler knows now that this is not legal, and is going to warn you that you shouldn't be doing that. And it's even going to tell you that it's going to fail on that value. So it can give you quite a good error message just because you stopped using enumeration. So don't use enumerations, ever. Just one thing. This is actually a warning, not a compilation failure. Something that's pretty important if you want to write correct Scala, turn on fatal warnings. I have had a lot of bugs found that way. I've never had a false positive. Scala C is very smart that way. Warnings, fix them. It's very important. Scala 3 might eventually deprecate enumeration in favor of the enum keyword. I have seen discussions on that matter. Last time I checked, it was not a proper ticket. There was not a proper pull request on that. But given that I haven't checked this week, and lots of things have been happening this week, it might actually be going on now. I don't know. But this is something that might actually disappear from the language. Sealed traits. So, right, I just told you sealed traits were nice. And now this is very similar to what I showed you before, but I believe something is wrong with that code. Does anybody have any idea why? Yes, you're in the back. A bit louder. Thank you. So, bar is not final. And the problem with that is when you see a sealed trait, and I've just given you the definition, sealed means you can't have a subtype, you can't have a direct subtype outside of the file in which the type was declared. But direct is very important here. Most people don't really realize that. But bar is a direct subtype of foo. And you can only have bar as a direct subtype of foo anywhere in the rest of the code. Bar itself, though, it is not final, so you can go into another file and declare a subtype of bar. And foo bar here is not a direct subtype of foo because there's a level of indirection, there's bar in the middle. So this is correct. This is perfectly valid. This is exactly how sealed is supposed to behave. It's also for people who have just learned about sealed, not at all what you'd expect, and it can be very surprising. So it's not a huge deal, and sometimes it's what you might want to do. But you have to know that it behaves that way, and unless you have a good reason for subtypes of a sealed trait not to be final, do make them final or seal themselves, because it's a good default. It's not an absolute rule, but it's a good default unless you have reasons to not follow that rule. Right, so solution is to prefer final sealed descendants. And as far as I can tell, nothing's changed in either 2.13 or .e about that. Right. Algebraic data types. So I showed you that just before. It's basically the same code. And now something's wrong with that. Something's a bit weird with that. Yes, you're in the back. Right, so this is a very good answer, but to the wrong slide. No, but that's going to come up very soon, so keep that answer and then answer it. I think it's 2 slides down the road. I'm not going to repeat it because I don't want everybody to know the answers to the next trick. But no, the problem here is that the Scala compiler can sometimes infer some pretty wonky types. So here, if you create a list of status OK and status not OK, you'd expect the type to be list of status. And instead, you get this abomination, which doesn't really change all that much. But again, this is from the perspective of somebody learning the language, somebody who's new to the language and trying to work out how the bloody thing works. And when they see that, they can't help but think this is magic. And it is magic a bit, and it's not what you'd expect, and you don't understand why you have that. And the reason for that is perfectly coherent. It's even possible for some people to explain it. I'm going to attempt it, not sure whether you're going to get it. But the reason this happens is that because here, Scala is going to try and find the closest possible subtype that is supertype that is common to both OK and not OK. One of these types is status, because OK and not OK extend status. But that's not all, because by virtue of being case objects, OK and not OK also extend implicitly serializable and product, which you don't need to know. It's absolutely not interesting at all. It's implementation detail. But it means that the least upper bound, so the closest supertype that is common to both of them, is product with serializable, with status. It's an implementation detail that leaks out to the user who really doesn't want to hear about that and who gets really confused. And when you have to explain that, what I just said, to people who are learning Scala, you lose about 50% of them. Yeah, okay, Scala is a bit magic. I don't want that. Let me get back to JavaScript. So that doesn't really work. And the way to trick the compiler into doing what you expect is to have your ADT extend product with serializable, because all of a sudden, magically, OK do extend status and product and serializable, not okay as well, but both of them, but status is also a product and a serializable, and so the least upper bound is going to be status. So this works. This behaves as expected. Scala 3 kind of improves on that by trying to hide it. So the enum keywords will by default not return the type that you expect. They return the supertype, but it still can happen if you use constructors directly. So details are not super interesting. If you want to read about that, this is clickable. Once I link the slides at the end of the talk, you can go and have a look at how this works. But so Dotty makes this better, but it's not fixed. It's just kind of hidden under the rug. There we go. That was your answer. So what's the problem with that case class? And the answer was, this case class is non-final. And if it's non-final, then you get really weird behaviors. That was, in a sense, your answer, right? So an example of bad behavior is foo being non-final. I'm allowed to extend it here. And I've created a class bar with two members, I and s, which are instance strings. And I maps to foo's I. That's not a problem. And then we have the additional string member. And this means that this code here is going to compile, and it's going to return true, which is not what anybody sane would expect. And I've actually taken the most obviously, the easiest example to understand, because what happens if you put these two, and back there, if you put these two in a hash map, is that one of them is going to override the other, and you're never going to figure out what. And when that happens in production, and you don't know why you're losing elements, it's happened to me. I hope it doesn't happen to you. It's a proper nightmare. So the reason for that, because I promised Daniela that I'd explain why this happens. If some of you guys have some Java experience, what happens here is that foo, being a case class, gets a lot of synthetic code, lots of methods generated for it, such as equals, toString, hashcode, all these kind of things. And so foo has an equals method that is implemented in a way that makes sense. Foo basically wraps an int. So if we have two foos that have two ints that have the same value, then both of them are equal. And that makes sense. But when you extend, when you subtype foo, then bar inherits from the same equals method. And so when you call that, the method that's going to be called is the method, sorry, this is a bit fiddly. The equals method defined in foo, which doesn't even know there's an s field that's a string. So this is absolutely normal. This is exactly what's expected when you know what's going on. It's also super confusing and really does make the language feel like magic. So prefer making final case classes. The reason why this is not the default is apparently there's one person in the whole entire world that does declare non-final case classes and has a use case from it. That person is apparently Martin Odersky. So when that happens, you don't get to change it. I wish it did change, but unfortunately, nothing's changing in either 2.13 or Dotty. So when you declare a case class, make it final, please. That's going to save a lot of pain in the end. Custom extractors, right. Does everybody know what a custom extractor is? I'll take that as a yes. So what's going on here is I'm declaring an object extract sum with an apply method that for any sum is going to return a value of type option of A. And this allows me to use extract sum in a pattern match. And this is really very wrong. And does anybody know why? When I found out, I got kind of angry. Does anybody know what's wrong with that? Nope. Okay. Have fun working it out. So what happens here, when you do that, this code here is going to compile. No problem. Even though it's quite clear that given the fact that my unapply method only takes a sum, it's not defined for none, it's quite clear that here, if my O is a none, which it can be, this is going to crash at runtime because the pattern match is non-exhaustive. But the compiler doesn't know that somehow. and this will fail at runtime. It's perfectly valid code, but the compiler cannot work out that it has a problem. So the reason for that was explained to me. It basically boils down to, doesn't really work, that thing. And I'm not going to try to explain it. So pattern matching, exhaustivity checking is quite wonky in Scala 2.12. And in order to avoid this kind of problem, the best solution would be to never define custom extractors if you can do that. But if you can't, try to make irrefutable extractors return some rather than option, because that actually fixes the issue, and you do get the expected warning here. Scala 3 makes this whole thing a lot better. There has been a lot of research done on exhaustivity checking for pattern matches. And so the problem is completely gone in Dotty, and you don't need to worry about it as soon as you move to Scala 3. But until then, be careful with custom extractors. They're weird. Structural types. Do I need to give a quick explanation about what a structural type is? Would anybody like that? Seeing a couple of nods. Okay. Structural typing is, for those of you who have used dynamic languages, this is duck typing, but in a statically typed language. This allows me to say that my add1 method here will accept any type, provided that type defines a get method that returns an int. And then I can just call that method. Because the only thing I know about that x value is that it's got a get method. So I get that, and I return, and I add 1, and that's what I return. And then, quite conveniently, I can define this case class. Notice how it's final, important. That wraps an int, and define a get method on that. And I'm completely allowed to pass wrapper to my add1 method, even though I have not defined any hard subtyping relationship. So structural typing is a way to do subtyping without having to declare it beforehand. It's quite convenient. It's a great tool, but in Scala, it suffers from a few flaws. Does anybody know what those flaws are? Yes? Right, okay. So the gentleman said reflection, which basically covers my 2 points. This is implemented in Scala as reflection. So the compiler knows this works because it knows everything that is in wrapper. It knows that wrapper has a get, so it knows this can't fail. But at runtime, it's going to have to use reflection to dig into the value that it received, extract a method object, call that manually, and this is much more expensive than not doing anything. So it has a runtime cost. It's not a massive runtime cost, and that should not discourage you from using structural typing when it makes sense. But the other problem is that, at least on the JVM, this might not actually run at all, because it's possible in the JVM to disable runtime reflection as a configuration option through security managers. So the compiler is going to compile that. There's no problem with that code. But at runtime, you're going to find out that you can't actually do that, and you have no way of knowing that in advance. So the preferred approach is type classes, and I might have been a bit over-enthusiastic here, so I don't think I'll have the time to go through all the slides if I go through this whole thing. If anybody wants to know more about the type classes, I'm going to explain that after the talk, but I want to cover a few more of these before we're stopped. So I'm going to skip the explanation. If you know what a type class is, use that instead of a structural type. And Scala 3 does overall the entire structural type API, but I don't think it changes the core of the issue because the default implementation still relies on reflection. And I don't see any ways that it could be anything but reflection for most cases. So I don't think it's going to be fixed. It's improved, but not fixed at all. Exceptions. Can anybody tell me what's wrong with these 2 bits of code? Come again? Right. So parsint might throw a number format exception because most strings are not actually valid integers. And elementat might throw an array index out of bound exception or some such thing because I might be outside of the array's bound. And the problem with exceptions, well, there are very many problems with exceptions, but the one I've chosen to focus on here are, the first thing is, okay, so this one is not entirely honest, but it works wonders when you're trying to explain to other people. So what happens very often is I'm working with a Java programmer, reviewing the code that they wrote in Scala, and when they get invalid inputs, they'll throw an exception. And I'll point out that maybe you don't want to throw an exception, maybe exceptions should not be used, and they look at me like I'm crazy. I've been doing exceptions my whole life in Java. Why shouldn't I do that? What's wrong with them? And then what I do is I'll ask them, okay, would you use a goto statement in your code? Of course not. Nobody uses goto statements. There are famous papers written just about the fact that you should not be using goto statements. And then you ask, well then, what's the difference between a goto statement and an exception? Can you explain to me what the critical difference between the two are? And most of the time what happens is I get a bit of a blank for 30 seconds, then, oh, okay, and they get rid of the exception and we carry on. So this is not entirely honest on my part because there's very many differences between exceptions and goto statements. But there are a few critical similarities. The first one is the problem with the goto statement is when you're at the label of the goto statement, you have no idea where you're coming from. You could come from anywhere in the source code, so you don't know your state. And this is something that you have with exception as well. You don't know where the exception was thrown. You have no idea. You might have mutable state that is not in a state you'd expect. So you can't know. And this is very similar between goto statements and exceptions. It's kind of even worse for exceptions because when you write a goto statement, the compiler is going to fail if there's no associated label. So you know when you write a goto statement that it's going to go somewhere. With an exception, it's basically, I'm going to bail out now. Somebody catch me, otherwise crash. Don't know, don't care, your problem. And it's even worse. You don't know that anybody's going to handle it. You can't check that. So that's the first reason why I don't like exceptions. It's essentially a goto statement for all the wrong things that matter. It's unchecked in Scala. So this is specific to Scala and a few other languages. But in some languages, such as Java, exceptions are part of the type signature of the method that declares them. So the compiler can tell you, well, you haven't caught that exception, you haven't dealt with that error case, so please do that, and otherwise I'm not going to compile. But with Scala, the compiler completely ignores exception. You have no way, when you call a method that throws an exception, you have no way to know whether you have actually dealt with all possible error cases, and it might crash at runtime, and you have no way of checking that. And lastly, it's referentially opaque, which is a very barbaric term, which I'm going to explain now. So referential transparency is a property of code that we really like because it helps us reason about code at the local level. It means that when you have an expression, you can replace it by whatever it evaluates to without changing the meaning of the code. So you can ignore whatever else goes on around the whole thing and focus on that expression, that is all that matters. So an expression is said to be referentially transparent if you can put what it evaluates to in a variable and use the variable everywhere else. And throwing an exception, if it was referentially transparent, would mean that these two implementations would be the same. Because in that one, I have a test that doesn't make much sense. It's never going to be evaluated. But if false is true, then I'm going to throw an exception, otherwise return 2. And the other implementation does the referential transparent test thing, where it's going to put the result of that expression into a variable, and then it's going to use them in the rest of the code. And obviously, that doesn't actually work out. The first one will evaluate and terminate. The second one fails. So these two expressions are not equivalent, and so throwing exceptions is not referentially transparent, and you don't want to do that in your code because it leads to all sorts of headaches. You should, in as much as possible, prefer encoding your error types inside of the return type of your methods. So concretely, rather than throwing an element notify an exception, if you want to convey the absence of a value, return an option. If you have some sort of fancy error code or things like that, put it in an either. So the right side of the either is a successful path. The left side of the either is where it's the error code, the error message, whatever. And if you absolutely have to work with exceptions, like you're doing some Java interrupt, for example, try is going to help you. It's basically an either that contains an exception on the left. So if you have to use exceptions, use a try rather than an either. And unfortunately, nothing changed in Dotty about that. Now, I'm starting to put together things that we have said before. This is one almost completely valid way of encoding an error. So this is a very simplified ADT, which we talked about before, which is meant to encode all possible error cases when you try to connect to a database. And in order for the whole thing to fit in one slide, I've just declared two possible implementations. One which is the SQL you tried to run is not valid, and the other one is I tried to connect but lost the connection, please try again. And something is not ideal with that implementation, but it does have all the things I've said so far. It's a seal trait, it extends products reserializable, case objects everywhere. It follows all the rules I've given so far, but it's still not quite right. Does anyone know why or how you could improve on that? Okay. The problem with that is that a lot of API in the standard library rely on exceptions to convey errors, mostly try and future, and you have lots of libraries that will use future or will use try, and you can't stick your DB error inside a future or a try. So in order to work around that, what you're absolutely allowed to do is to use exceptions. But you're not throwing them, you're just tagging your type with an exception. And so DB error is now an exception with product and serializable. And you can absolutely stick values of type DB error in the left or in a try, or in a future. It's not a problem at all. So bit of a trick that, but it allows your exceptions, ADTs, to be a lot more usable when interacting with the Scala standard library. Right, the return keyword. Okay, what's wrong with that, aside from everything? Well done, the return keyword. So there's lots and lots and lots of reasons to not want to use return. We have the whole go-to statement thing again, it's basically the same discussion. Breaks referential transparency, again, same discussion. But mostly, it's just completely insane. It doesn't not at all do what you think it does. Come again? Well, we're going to go through that, right? So this code here looks kind of sane. This is what somebody who's come from JavaScript, for example, might write. It makes a lot of sense. You have a list of ints, and you want to map on it and add one to absolutely every single value in it. So you create an anonymous function which returns n plus 1. Unless you know to look for return, this makes a lot of sense. But the compiler doesn't quite agree. It's telling me that I've said it was a list of int, but it really should be an int. That doesn't make much sense to me. Mapping in a list should return a list, but compiler is often more smart than I am, so I'm going to trust it and play along. So I do what he suggests, and now this is not a list of ints, it's an int. New complaint should be a list of nothing. When nothing occurs in the type that you have inferred, something's really, really wrong. And I have no idea what's happening here, but I'm just going to follow the error messages. Back to it. Well, you found a list of nothing, but I really wanted an int. What the hell? So I don't know what's going on. I don't want to know what's going on. I don't want to understand what's going on. I don't use return. It makes no sense. You're going to try to understand it at some point. You won't. You will fail. You will remember that slide, and you will think, I should not have tried to understand it. Don't do it. It's a nightmare. Don't use return, ever. Just scrub it. And there are possible improvement in Scala 3 in that non-local return statements might be forbidden. I don't know what that means. So maybe it's a good thing. I don't know. Implicit conversions. Right. So this here, a method defined as implicit, means that it's an implicit conversion. So whenever the compiler is going to find a string that he would like to be an int, he's going to call this method and turn my string into an int. This looks pretty nice. It's pretty fun. Do you know what's wrong with that? Right, so if you're muttering it, I'm not going to hear it. Was that you that came up with the answer? Oh, it absolutely will throw an exception, because it lets you write beautiful code like that. Foo bar divided by 2, and the compiler is going to be very happy to compile that and carry on as if nothing happened. And this is basically you lying to the compiler. You're telling it, right, I know better than you do. This string, it's actually an int. And this is most of the time not true. There are infinitely many strings and infinitely many more strings that are not ints than strings that are ints. So this is going to break eventually, sooner rather than later. And you never want to do that. The main problem being that this implicit conversion is not total. So if this was total, so say transform ints into floats, it's iffy, but it's okay, because it can't fail at runtime. It's still weird, you're getting the types to lie to each other, but it will not fail at runtime. But this is horrible, and you don't want to do that. Instead, well, you could do this really nasty thing. Sorry. You could do this really nasty thing and be explicit about your conversions, or you could just try not to divide foobar with 2, because it doesn't make much sense. It's also a possibility. So this is, at least in Scala 2, there's a reason to have implicit conversions. This is how all libraries that expose type classes will allow you to add syntax. So this is how you can have the map method when you have a functor instance, for example. So it's pretty nice. And implicit conversions to enrich existing types are okay. They're also completely unneeded in Scala 3 because you have extension methods. So as soon as Scala 3 happens, stop using implicit conversions. The compiler is going to fight you over it anyway, because it's going to ask you to enable a compilation flag and then to be very explicit about it. In Scala 3, implicit conversions are kind of frowned upon, and this is a good thing. Implicit resolution. So I'm going to go through that one directly because it's a bit subtle. What happens here is I've defined a type config which contains a port for some sort of network configuration. And I've defined a getPort method that for any config value in scope is going to return the port. So that way you could implement a default configuration here. So by default, my configuration is going to have port 8080. And if I call getPort like that, then it's going to work out that the default implementation here and your default port is going to be 8080. It's quite a convenient mechanism, but in Scala it suffers from a pretty big problem, which has to do with implicit shadowing. So here in another object, I define a new implicit value of a completely different type. Default config here is of type config. Default config here is of type int. So the only thing they have in common is their name. And that should not have any impact, the name of a term, when you resolve types. But it does. When you import both A1 and A2, you get the dreaded could not find implicit value for parameter blah, blah, blah. And this is very confusing, because this is not what you'd expect. It's actually quite clear what happens when you remove the implicitness of this. If you were to import both A1 and A2 and ask the compiler to use default config, it's going to tell you, well, it's ambiguous. I have it both from A1 and A2. Which one do you want to use? And this is very clear, this error message. So when I don't have an implicit thing stuck in the middle, I understand what happens. But what actually happens is you get could not find implicit value for a parameter. And this is black magic to most people who start learning the language. This is extremely confusing. And the bad news, there is no real workaround. Provided that you don't have a perfectly unique name, it's going to happen eventually, and you can't guarantee that you're going to have a completely unique name. Anybody can be using the same name as you, and worst thing is here, when you do that, you might not know that A2 declares an implicit value of the wrong name, so you might have no idea that you're causing the problem. You don't know what you're importing, because you're importing everything. So this is very confusing to beginners, and when it happens, it's a nightmare to explain it. So when you do it, when you have to declare implicit values, give them silly names, really long names with your name in it, like Nicolas's fancy foobar instance for type int. It looks silly, but the whole point, it's an implicit value. Nobody's going to see the name. You're not supposed to manipulate the names of implicit values. So it's not a problem, but it's still not perfect. Somebody might also be called Nicolas and have the same naming conventions I do. So that might still be a problem. Luckily, in Scala 3, first, you have import implied, which means you know that you're importing implicit values. So it's less likely to happen because you can't do it by mistake. But more importantly, implicit name shadowing doesn't exist. So the problem just completely gone in Scala 3. So it's a major improvement. String concatenation. Can anybody tell me what's wrong with that? Excuse me? Okay, well, here, string concatenation. I'm using plus to do string concatenation. This is a mistake because plus is kind of insane. It doesn't behave very coherently. So here, I have a list of string, and I plus bar it. So I add another string to it, and this is going to return a string which has a value, not super interesting, but it's going to do that. On the other hand, if I have a set of strings, and I add bar, then it's going to add it to the collection, and it doesn't have the same type at all. So this is weird. When you know what happens underneath, you understand it, and you go, ha, ha, of course, what was I thinking? But when you try to explain that to somebody who's learning the language, of course it behaves that way. Can you not work out why? The person is going to look at you like you're nuts, and he's going to go away and never do Scala anymore. And I'm not even talking about this absolute nightmare, where you add 2 to a list of ints, and the compilation error is, well, I expected a string. Why? Why would you expect a string? Again, it makes sense when you know that any two-string add is a thing. If you do know that any two-string add does exist and you know what it does, I'm sorry for your pain. I went through it as well. I think it's deprecated. It is deprecated in 2.13, has been removed from 2.14, magically back in Scala 3. I'm not sure why. I think it's just that Scala 3 hasn't been rebased onto the 2.13 standard library. I hope. But so instead, don't use string concatenation. Use string interpolation instead. This is first, I find a lot more readable, and it doesn't have the same problem because it's not using plus. And also, yesterday, Daniela was making the point that string concatenation is much slower than string interpolation. So there's that as well. If you care about efficiency, use string interpolation. In conclusion, how do we enforce best practices? How do we make sure that all of this stuff that I have shown you, and there's a lot more where that came from, I've just picked the best. How do we make sure that this thing doesn't crop up in your code? Well, first, code reviews. I know that a lot of people don't actually like code reviews, but there's some very solid research that proves that code reviews actually does drastically reduce the amount of defects in software. So when you get the slide, you can click that. It's going to link you to the publications to that effect. Do code reviews. It's great, and it helps you avoid these things, and it helps you teach them to people who don't know them. Use tools that automate the finding of these problems. So that's a bunch of, I think that at the moment, that's all that exists, but the landscape keeps changing, and we're apparently very big on tooling at the moment, so I wouldn't be surprised that by next week we have another one. But at the moment, you've got Scapegoat, What Remover, Scala Linter, Scala Style, Scala C, especially if you go through Rob Norris's post on the subject, which makes Scala kind of sane again, and Scala Fix. So all these tools are going to make your code much, much more reliable. Also, switch to Scala 3 as soon as you can, because as you could see, it fixed a lot of the problems that I had. These were my favorite, well, either bad or best practices, depending on which way you look at it. There's a lot more than them, and I'm pretty sure I don't know all of them. So if you guys have things that you think I should have talked about and I haven't, I'd love to hear about them, I'd love to learn a bit more, and I'd love to include them into my next version of this talk or into the website that I've created to go with that. I wanted to thank the Scala contributors and Dotty GitHub channel, especially Guillaume Martre. I don't know whether he's here, but he's basically written all of the future improvement sections. He's basically a living database. Whenever I ask something like, but how does that work? Oh, not a problem. Here, publication. Here, ticket. Here, merge request. 5 seconds. He knew the URLs by heart. I don't know how he does that. He's really quite impressive. But if you're wondering about Scala weirdness in the language or how these weirdnesses are going to be fixed in the future, these 2 GitHub channels are really, really great. More information. So the slides are already available here. And if you want to have proper articles on all of these rules and more, There's a companion site at this URL where I took the time to write these things down properly, not just as slides. You can follow me on Twitter. I work for Besedo, blah, blah, blah. This is all done with Remark.js and Tut. I don't know if Rabnar is still here. I saw him before. Tut is an amazing tool that will make sure that all the code you saw in these slides is correct and evaluates to what you've seen because it's actually executed when the slides are compiled. So it's not possible to get the slide to compile and not show the truth. And do we have any questions? Thank you. Yes.
Yes, thank you. Thank you first, and I have a question. Where is the Scala fix, and is it possible to add such cases, what you described, to be automatically reported?
Right, so that's the point of the automated tool. So was the first part of your question, where is Scala fix? Because, right, what is or where is? What is? What's your question? What is Scala? Come again? Okay, right. And so these tools will automatically analyze your code and fail your build if they find one of these patterns. They're pretty opinionated. What remover in particular is really hardcore in what it reports. You can turn off some things that you might not agree with. For example, I know that what remover is going to fail any code that defines default value for methods, but sometimes it's quite important to have them, so I don't actually agree with that what. So, but all these tools will fail your build if they find some sort of pattern, and you can pick and choose and add whatever you want and get. I mean, I think that all the things I showed here are reported by one of these tools. Turn to the man in the back.
I have a question about using try.
Right.
In every place where exception may happen. I have experience that such pure way may occur in some try orgy. So you write a code and you land with code where in every place you should somehow handle a try. Don't you think that, do you have any experience that maybe it will be some threshold that, okay, in these cases I should use a try, but there are some cases where a throw exception is completely okay?
Right, absolutely. No, this is a very good question. So exceptions are absolutely okay, provided they actually are exceptional. So if you run into an error such as CPU not found, it's okay to crash. So you're probably not going to be able to recover from that. But the examples I gave here were, for example, string to int and number format exception. Most strings are not ints. It's not the exceptional case. It's a common case that this is a failure. So this is not an exceptional exception. It's an expected exception. And you should not use an exception for that. You should use a return type. But for anything that you're not likely to survive from, or that just doesn't make any sense, just let that go, absolutely. Let fatal errors be thrown. That's not a problem at all. You don't really have much of a choice anyway. I mean, if you don't have a CPU, just what am I going to do anyway? Any further question? Gentleman over there. Oh, you don't have time. Oh, sorry. Right. Okay. So I don't have time for public questions. I will be here if you have further questions. Don't hesitate to come over and ask them. And that's me done. Thank you very much.